Hey, this is a video for students that missed class on Monday, June 1st. What we're going to be using is at bit.ly/circtool. Capitalize the C and the T. It is case sensitive. Okay. And what you're going to do is you're going to go to that circle tool and you're going to construct a circle with a radius 10. And the center of the circle needs to be on the origin. So basically you're just changing your C value to 10, leaving everything else alone, just changing C to 10, and that'll give you a circle with a radius length 10. And we're going to talk all about the equation of a circle today. Hopefully by the end you'll be able to look at a circle and write the equation, look at an equation and graph the circle, look at the equation and tell me the parts of the circle, the measurements. Okay, so that's what we're working on today. Okay, this is what your circle's going to look like on your circle tool. All we did is we came over here and we changed C to 10. Everything else stayed 0, 0, 0. Just change your C to 10. There's your circle with a radius of 10. And this is what we're going to use today. We are in the textbook, chapter 12, section 12.1.1. So you can follow along in the textbook or in the guided notes that I copied from the textbook. So what do all the points in this circle have in common? So this point, this point, this point, this point over here, this point here, this one here, every point along this circle, what do they all have in common? What they all have in common is that they're all 10 units away from the center of the circle. And that's the definition of a circle, if you recall. A set of points that are equidistant from a center point. So that means all of these are just a set of points that are 10 away from the center. Okay, it says find all the points on the circle where x equals 6. So I'm going to just make a dot where x equals 6 here. Maybe. Okay, and here. There's my two places where x equals 6. Okay. What is the y value there? So we know that my x value is 6 in these ordered pairs. What's my y value? Well, we can tell by looking. My y value is right here. It's 8, right? And at this point, my y value is negative 8. Okay, so we can tell by looking, but there will be times when we aren't able to tell by looking. So we're going to need to know how to actually find that 8 or that negative 8 or that y value. Okay, luckily, we know right triangle geometry. So if I've got a point here at 6, and I'm drawing a line from the center to the point at 6. I'm drawing a line from the x-axis up and from the center out the x-axis. And that, whoops, is not the way you show a right angle. That's a right angle. That's a right triangle. And there's something that we know about right triangles. If we know that the length of this is 6, and we know this is the radius, so we know that's length 10, we can find this y value, even if we can't tell from the graph what it is, even if it's not on a lattice point. So we can tell by using the Pythagorean theorem. So 6 squared plus whatever that y value is squared equals 10 squared. So that means y squared equals 100 minus 36. So y squared is 64. Which means y is, when you square root 64, you could get 8 or you could get negative 8. And of course we knew that that's what we were going to get already. But like I said, if it's not on a lattice point, you're not going to know. You're going to need to do this math. So what I'm going to want you to do now is pause the video and try this next part yourself and then come back and see how you did. So it says, what if x is 3? So where x is 3, right there, that's not really on a lattice point. We can't tell what y is. We can tell that y is somewhere between 9 and 10, but we don't know exactly where. And also down here, y is 3. Okay. So I want you to use a right triangle to do this and find the corresponding y value. When x is 3, what is y? Okay, in both of those spots. Pause the video and then give it a try. Okay, so what we've got, if we're going to make our right triangle again, is we've got, here's our hypotenuse. We know that's 10. I didn't really make that long enough. Okay, and then, all right, that's probably about the best right triangle I can manage on an iPad. Okay, we know this is 10 long. We know this is 3 long. We're trying to find the y. So we used our Pythagorean theorem, 3 squared plus y squared equals 10 squared. So y squared equals 100 minus 9. So y squared is 100 minus 9 is 91. Which means if we take the square root of each side, we get y equals a positive or a negative root 91. And if you put it between in your calculator, you're going to see that that will put you right between 9 and 10, right about here. Okay. Let's go to the next page. Mia picked a random point on the circle and labeled it x, y. Unfortunately, she does not know the value of x or y. Help her write an equation that relates x, y, and 10 based on her diagram. So she put it up here somewhere. We're not exactly sure what that point is. It's not at a lattice point, so we can't tell. But again, we do know that that's 10. Because that's our radius, and we know we made a radius 10. We do not, however, really know what that is. So we're just going to label it x and y. So what is the equation here? What is the Pythagorean theorem that we're going to use here? Well, it's going to be x squared plus y squared equals 10 squared, or we could write it x squared plus y squared equals 100. This is the equation for this circle. If you pop this equation right here into your calculator, well, if you have a fancy calculator, or if you plug it into Desmos, you're going to get this exact circle. This is the formula, the equation that creates that circle. Does your equation work for the points 10, 0 and 0, 10? Well, you just plug them in and see. 10, 0, well, this would be 10 squared plus 0 squared equals 100. Does that work? It sure does. What about negative 8, negative 6? Let's try it. Negative 8 squared plus negative 6 squared equals 100. Well, that is 64. That is 36. 64 plus 36 is 100. So yes, it works. If the point is on this circle, it works. What if the radius were 4 units long instead of the 10? What would the equation of this circle be? Write it down and then come and see if you were right. Okay, the equation of a circle that is 4 units long radius would be x squared plus y squared equals 4 squared, and we know that 4 squared is 16. So this is the equation of this circle with a radius of 4. Okay, now it says write one with a radius of r. Go ahead and try that. Write me an equation with a circle with a radius of r. Okay, hopefully you got x squared plus y squared equals r squared. That is the equation of a circle centered at the origin that has a radius of r. So knowing this, knowing that this is the x coordinate, this is the y coordinate, okay, and this is your radius. Knowing this, we can graph any circle without making a table of values. For example, if you look at this one, what is the radius of a circle with an equation x squared plus y squared equals 36? The radius is 6. So I could very quickly sketch a graph. I could just go from my origin out 6 on all sides and just sketch my graph of my circle without making a table of values. What would the graph of x squared plus y squared equals 0 look like? Well, what's my radius? My radius, square root of 0 is 0. What does a circle with a radius of 0 looks like? It looks like that. It's just a dot. It's just a point at the origin. We call these circles that just have a radius of 0, we call them a degenerate circle. Degenerate circle. Okay. I'm going to come back with a second video to talk about circles that don't have a center at the origin, and we'll talk about how to write the equations for those in the next video.